Hello and welcome back to the lab. Today on the bench we have another one of these. In this case it is a Tech 465, not 45, 465B. This one has the DM44 on top. And we have a reject sticker up here on the front. Typically when these get rejected like this, they either have grossly failed or they have a calibration issue. They did not validate their last calibration. And it looks like it was rejected in 01. So this one's been off for a bit. The condition on this one is dirty but decent. Not sure what that is. That's in the metal. That's marker. A couple of stickers, a reject, and we'll go from there. So let's see if we can get this cleaned up and functioning again. I'm going to take you guys through the process of bringing this back to life. So we'll do some basic preliminary checks before we even pull the covers off. This does have a linear supply in it, so I can actually spin this up slowly on a variac, which we'll do. The 485 and the 7000 frames, they actually have a switching supply and should not be spun up on a variac. But let's move this down to the isolated supply. Turn the scope on. There won't be any voltage there, I'm sure. And we'll start giving it some volts and see what kind of current we draw. And the bench isn't warming up, so I have a problem with the isolation transformer. A cord was just a bit loose. So we'll bring this up. We'll give it about 20 volts, 30 volts, and we're drawing about 4 watts. That's not terrible. Nowhere near enough to wake the scope up, but we don't have dead shorts across the primary windings, which is always good. Give it a bit more. Starting to see some signs of life. And still drawing about 37 watts at 75 volts. I don't want it to sit here for too long, so we'll bring it up to 115. See if we don't get a trace. All right, so there's 115 volts. All right, uncow. Okay, we have green. So for whatever reason, we don't have sweep. Auto, it should be sweeping. So, oh, there's the line. There it is. It was vertical. It was just off the screen. So we have a trace. Good trace width. Everything looks good. So having a trace confirms that we have high voltage. This is starting to be sensible. This isn't nonsense. Turn on channel 2 as well. We can get 2 traces, so that's good. Chop. Channel 2 and chop. Yep, alternate out. The buttons are sticky a little bit, which I would expect. Anything of this vintage definitely needs a cleaning and the controls serviced. That is no surprise. But we're ready to go. So since we have a trace, let's toss the calibrators on it and just give it a quick check-in calibration. See if my suspicions hold that this thing failed cal in some way. So I got 0.1 time marks, 0.1 millisecond time marks coming out of the function generator, and we're on 0.1. Flip this over to DC. Bring this down. Turn up some brightness. Oh, well, that's That's bad. Let me zoom in on that. So as you can see, our time marks we are slow. I'm lined up pretty good over here on this side. But as we go, the sweep slows down, and this marker should be right here. The time mark generator that I'm using is stabilized on the Labs Rubidium, so I have confidence in the time mark generator, so that explains the reject sticker. The time base is going to need a bit of help. This one's a bit slow. See if we can match it up, see if it's how slow. I'll use the camera, see if we can't dial this in a bit. So that's more about what it should look like. And we're running about 5% slow. So spec on this scope is 3%. 5% is going to fail. And so this absolutely needs adjustment. So covers are coming off, and at best, this needs a cleaning and a calibration. All right, one thing we want to change is this. So where I'm at, line voltage is running about 123 volts. This is set for 115. So it's running a bit hot for the regulators. Now the regulators are keeping everything in spec, at least in theory. But this is putting some stress on the regulators a bit. So if we move the transformer taps up to the top for 108 to 230 volts, we'll take some stress off of the regulators on the power supply. Now, one of the things that's absolutely critical in doing one of these 400 series is the ripple on the power supplies. Tech had a habit of using tantalum capacitors pretty close to their rated maximums. AC ripple plus the DC can push them over their rated voltage, which causes them to short. So having the the ripple spec on a scope like this is very, very tight, but it's also tight and should be. I'll take the accessory bag off, and should be kept low for the health of the tantalums too. The tantalums are usually okay as long as they don't get overvolted, but they are very sensitive to overvoltage and get cranky pretty quickly. If you are working on one of these ones with the meter on the top side, the DM44, the calibration, especially the horizontal calibration, which is where we're having trouble, is kind of funny. The horizontal circuits come up to the meter and then go back into the scope. So what we're going to need to do is do the scope calibration up through the 465B manual until we hit the horizontal. Once we hit the horizontal, then we have to flip over to the DM44 manual to finish up the horizontal calibration. So it can be a little involved. Doing an alignment on one of these does take quite a while. There's a lot of test points, lots of things that need to be adjusted. So it can take a good 6+ hours of bench time to get one of these things aligned. Covers off. So for those who haven't been in a 400 series scope before, DM44 is on the top. Over here we have the vertical section, the vertical attenuators, vertical amplifier. Delay line pops in on the back side of that board. No. Delay line is hiding right there. There's the delay line. Lots of tantalum capacitors that can short out, so definitely something to be aware of. The horizontal, this is the trigger board. Horizontal sweep board's actually behind here. Getting into these things can sometimes be entertaining. And we have high voltage supply, power supply, some sweep and focus sections. I I did one where this cap was burned up, took a couple resistors with it. That caused some sweep problems. Voltage test points are going to be right in this area. Main rectifiers for the supplies and capacitors are there. Pass elements are down here on the side. And high voltage CRT switching stuff is under the cover. A lot of these style of switches that need to be cleaned and serviced, especially the beam finder. So this switch, definitely give this one a cleaning. The beam finder switch is directly in the deflection plates path and can cause, if it gets dirty, it can cause weird things to happen with the traces on the CRT. Okay, one thing I want to sanity check is the DMM to start. I'm on the 200 volt range. I've got this hooked up to a calibrator that is not warmed up, but I just want to see ballpark. Something's not happy. See if it's my standard that's messed up. Well, it's not my standard, so this is not reading correctly. Something's wrong with this DM44. Let's see here. Clean some switches real quick. Drop it back down to 20, see if that range operates even better. So this is starting to look like we definitely have a meter problem. Okay, so it's not calibrated, but the 20 volt range is working okay. Still maybe need to clean this switch pack. So that was good. How about the 200 volt range again? Okay, yeah, dirty switches. So I asked it for 120 volts. It's off by a bit. Definitely probably needs calibration. I have much more confidence in my, actually, 120 volts. So, yep. Clean the switches. And, because I was going to say I have much more confidence in my standard than I do in this meter at the moment, but this meter's now looking pretty good. If I bump this to 150, that looks perfectly happy. We can go above. 1.2 kilovolts is an odd range, but we'll go to, we'll hit 950. We'll make it spicy. Yeah, no. Needs some help on the high range. Just exercise the switches a bit, see if it comes good. Yeah, so it was a switch problem. I asked for 950 volts, 953. So it's dirty contacts. That's not going to be a problem. All right, so, well, that's not terrible. Okay, so the DM44 at least has some form of a brain. We can check the auto, see if auto actually works. Auto would be a 20 megohm input impedance, and we'll hit operate. There should be 10 volts. More dirty switches, but auto's now probably going to work. We'll give it 100. Yep. So it's that should be 110. It's a little off because it's dirty, more dirty switches. So I have lots of cleaning ahead of me. Through the magic of the camera, I will work on getting all the switches all cleaned up, serviced, and all that other stuff, and bring you guys back when we are checking out some things after we're done. All right, we'll check some DC power rails. I've got the scope turned on. If you are following along, you are doing so at your own risk. Please take care. Some of these measurements you do have to do with the equipment on and powered up. We are working around elevated voltages. All right, got a good ground connection. So this is supposed to be plus 110 volts. 112 isn't too bad. We're going to come back through and do AC for ripple. So plus 5. Oh, that looks good. Plus 55, which in this scope is actually the reference rail for all the other power supplies. So being off by 41 millivolts is not bad. That's perfectly acceptable. But that one has the tightest spec of all the power rails. This is plus 15. $14.99, that's not bad. This is 8. -8, so that's also okay. So because my regulated rails are fine, my unregulated rails are going to be fine. Let's flip this over to AC, and we'll check some ripple. So we'll go back to the 110 volt rail. 5 millivolts of ripple on a 110 volt rail. I believe that makes spec. Plus 5. Now, because this is a lighter rail, the ripple spec's a lot tighter. Yep, that one's going to be fine. The plus 55. That's fine for ripple. Nice and clean power rails. Power supply in this is looking pretty good. That is the, what is that? That is the plus 15 volt rail, and we'll check the -8. Yeah, so the voltage and ripple are fine on the rails, so the power supply is in good shape. We can move forward with cleaning and calibration. Okay, in a previous clip, I mentioned that this was an auto setting. It's not. This is a 20 megohm input, 20 megohm range for the ohms range, and has nothing to do with the voltmeter. So this is not an auto ranging meter, and it does go up to 1 kilovolt or 1.2 kilovolts, and it tests fine at 900 megs. So that's not going to be a problem. However, let's take a look at some channels, because man, this thing needs help. Okay, I have a waveform coming in to this unit from the PG506 calibrator. I've got 20 volts peak to peak coming out, and we can already see some problems. I'll zoom in here. This scope is looking pretty sick and is going to need some help. Definitely cleaning on the pots and everything like that. I think the pots cleaning is going to make some of this stuff come back, but we have a sweep length problem where the sweep is starting at the 2nd division and ending at the 9th. I don't have full span sweep. I can get full span sweep if I hit 10x, but I don't have full span sweep at 1x, so I have a sweep length problem. I have an amplitude problem. With 20 volts peak to peak at a 5 volts per division. I should have 4 divisions of display. We have 1, 2, 3, 4 and a half. So we're actually above 8% high on this one. Channel 1 is also off. So it's safe to say pretty much everything calibration-wise on this scope is out for some reason. Sweep length is out. Speed is out. We know the horizontal section's out. The vertical sections are out. This scope definitely needs some help. I can see why it had a rejection sticker on it. But most of these should be calibration issues. The one issue that bothers me a little bit is this sweep length problem. Like, I can spin. I can send it from side to side, and if I do that and I clean this pot up, it'll pop back and forth in terms of length. Oh yeah, graticular illumination works. Other than that, the tube is in great shape. Like, the tube has plenty of life left on it. Great intensity on the tube. So definitely worth fixing. But I got some work I got to do on this one. It is not a happy scope. This little weird thing is there's some adhesive on the plexiglass that hasn't come off yet. So this kind of starburst where the trace is not a problem. That's just cleaning of the plexi. So our DMM's working. Our time base is not. Our vertical's not. Our trigger's good, although there are some trigger control problems that I have to fix. This control right here is slipping and not doing its job, so that needs to be tightened down and adjusted. All in all, got our work cut out for us. But you can check one real quick. And channel 1, same 20 volts per division. We are better. We're better, but we're still off. So yeah, we got some work to do on this guy. Well, as I was troubleshooting, I heard that all too familiar electrical snap, and the horizontal flew off the screen. So, been poking around in this section down here, and I noticed, took me a while to find it because it's really hard to see. Right here, this diode is all fogged up and dead. So I got to pull up a service manual, see what this diode is doing, and then also see what associated components might be trouble with that. I'm also going to just buzz out all these diodes here just to make sure they're okay. But I definitely have to replace that one. All right, so we had a bit of technician error on the last one. It wasn't the diode that went, it was the cap that I'd put in. Apparently I got the polarity backwards, and the cap exploded. Not violently, but it's a 16-volt cap with like 4 volts across it, but it's still pressurized, expanded, and got cranky. Blue electrolyte all over the place. Had to clean the board up, do all kinds of stuff. But I got a new cap put in. Correct polarity this time. Let's see if our sweep problem has gone away. Okay, so we're better. Oh, look, there it is. So we're back to this control being a little dodgy, but that's now a full sweep, so that's not bad. Nope. Just went bad again. All right, so let's see if we can't nail that down. It's wildly intermittent, which is frustrating. All right, well, I think I found a culprit. Troubleshooting technique, especially when you have an electromechanical problem, a non-conductive tool, and gently tap on the affected area and see if you get a change. Sometimes it tells you something, sometimes it doesn't. In this case, tapping on the output transistors, nothing. Another suspect would be the tuning capacitors, nothing there. Those are an electromechanical. And then I started tapping on some of the potentiometers, and then I hit this one. And as you can see, as I move my hand over here, just ever so gently tapping that pot gets it to go. And it looks like tweaking that a bit, since I'm going to be doing a full recalibration on this scope anyway, it was just a dirty contact. The pot in question is the 1x gain, which makes sense because the 1x gain affects the 10x gain and everything else. I do need to fix the 10x switch. That's going to be next on the list. That switch needs lubrication. and cleaning. All right, so we got one thing done. My sweep is now in better shape. 1x gain will be completely readjusted, so adjusting that isn't going to be a problem because I'm going to do a full alignment on this anyway. But so our sweep width was a dirty potentiometer. Okay, I have spot checked the meter. On the 20 megohm range, it read 11 megohms, 0 problems. So the ohms range is good. The time range, I think I'm still out, especially with the sweep being slow. But the scope is now behaving. The traces are stable. Everything is starting to look okay. So it's now time to dive into the calibration document. I've done an extensive calibration on a 465B earlier in the channel. So I'm not going to record, at least on this one, I'm not going to re-record the entire calibration process. It is one of the earlier videos, but check it out, and it goes into the calibration process very in depth. But I think this one's going to be all right after an alignment. I did fix the knob over here, so this is actually actuating now like it's supposed to. And it's not spinning around anymore. That was just tightening up the set screw. So what I'm going to do, through the magic of the camera, you guys won't have to wait, but I'm going to go through the 6-hour bench process of aligning one of these things. It is incredibly in-depth. I think it's 36, 40 pages, something like that, of adjustment points. There's lots of pots in one of these to tweak and fiddle. But when we come back, if anything doesn't go through calibration and another error crops up, I'll bring you guys back. We'll troubleshoot that error and continue on bringing this 465B back to life. But as of right now, the scope looks okay, out of cal, but at least functioning. And the DMM actually seems to have held its calibration pretty well, especially on the voltage and resistance ranges. All right, I'm almost through the alignment. Some things are making sense. Gear's fighting me, of course, but here we are. I had a pot fall apart on me. The top popped off of the 1x gain pot, not to be confused with the 1x horizontal pot. So the 1x gain, which is over here, is for XY mode, and the 1x that is over here is for the sweep. So I got the sweep lined up, everything's good to go there, but I was messing around with the 1x gain, and the pot fell apart. The top fell off, which is the part that traces the resistive element, and the potentiometer failed. So that is, even though I could snap the top of the pot back on, I'm not going to let a piece of gear leave the bench that way, so we ended up replacing the pot. I'll zoom in. The pot in question is right here. And that one was kind of fun to get to without tearing the entire bottom board out. I was able to do it without pulling the board, but I had to use the micro soldering iron, put some flux on the board. I still need to clean the flux off a little bit and get everything all cleaned up, but I was able to swap it out, and it was able to calibrate. Now, an interesting thing on the calibration that I ran into is this is the 20 millivolt calibration from my standard amplitude calibrator. I trust that piece of equipment. It is in very good shape and works as expected. I was a little confused because I tried my HP 8657A. So I tried my 8657A to see what kind of signal we were getting, because I can do up to 2 volts into 50 ohms. And I figured, 50 kilohertz, 20 millivolts into a 50 ohm terminator. But my amplitude is way higher than 20 millivolts. So I found that out the hard way and was scratching my head for a little bit, thinking I may have botched up the repair, but my gear was lying to me. Okay, so I have no idea what happened to this scope prior to it hitting the bench, but this one was a bit weird. Obviously, we had problems with the rejection, things like that, and we know there's calibration issues, or there was calibration issues with it. However, after probably 60% calibration, it's actually in pretty good shape. The step response was good on it. I have it showing some time marks right now, 0.1 millisecond time marks. The time base is now dead on. The amplitude is good as well. Let's just pick one here for a second. What are we at? 0.5. So that's going to be 2 volts per division coming out of the PG506, and we have a very nice amplitude. So had some stuff on the vertical gain, definitely had some stuff on the horizontal gain that was a little bit messed up. But other than that, turned out pretty good. The one thing that I was really, really surprised with this particular calibration is the step response was actually pretty good, and the 3 dB point on this scope is dead on 100 megahertz. The 465Bs are known for being able to exceed 100 megahertz. They were tuned down to 100 megahertz. The 465 non-Bs sometimes struggle to hit that 100 megahertz 3 dB down point. This one was hitting it, so I could probably tweak it up a little bit more, but the step response is incredibly good on this one at the moment. So I don't need to tweak too much there. Let me get this all closed back up and toss the covers back on. I did voltage check the DMM, and I also resistance checked the DMM, and it's bang on. The standards read exactly what they're supposed to, and my decade resistor box is completely happy on that DMM. So the DM44 is in great shape and doesn't need an alignment. And the covers are back on, complete with bag and tilting bail. To pull this reject sticker off. Thanks for stopping by the lab and taking a look at this 465B and DM44 scope repair video. If you like what you see, hit the subscribe button, like, share the video, and hang around. Thanks again to all the patrons who help keep the lights on here in the lab and videos coming up to YouTube. As always, more is on the way. This particular scope is completely surplus to my needs. I do not need another 100 megahertz scope here in the lab. So if you know anybody who needs a scope, interested in a scope, wants a scope, hit the website and see what's listed up there, or hit me up in an email and we'll see if we can get this homed to somebody who will use it for quite some time. And with that, more is on the way, and I will see everybody in the next video.